All right, so today we're going to do one more problem similar to what you did in the last video, only this time we're going to be in radian mode. And this is going to be mostly the same. The main difference is our calculator will be set in radian mode. When we are solving algebraically, we'll also have to use the radian version of our general solutions. But the beginning part is going to be pretty much the same. So yesterday, we gave you a graph like this. In fact, I think it was the same graph. But yesterday's graph, our x was in degrees, and now I'm saying that the x-coordinate here is in radians. So I want to come up with an equation. You can use sine or cosine. Oh, it says using cosine, so we're going to use cosine. I think cosine's easier. Couple things we need. We need our period, we need our sinusoidal axis, we need our amplitude, and we need our phase displacement to write this equation. So first, we'll start with, let's find the sinusoidal axis. If the very top is at 7 and the very bottom is at -1, that makes this thing 8 tall. So I guess I'm going to start with the amplitude. If its total height is 8, then my amplitude is half of that, which is 4. And if I go up 4 from the top or down 4 from the bottom, I find my sinusoidal axis, which is going to be at 3. All right, so I've got those parts. My phase displacement, if I'm using cosine, cosine normally starts with this highest point on the y-axis. So since it is over to the 2, we have our phase displacement is 2. And then I need the period. So I start at 2 at my highest point. I come back to the highest point at 14. This distance right there is 14 minus 2, or 12, so that is my period. Period is 12. If I put all this together, I can write my equation. This here. So I take y equals, my sinusoidal axis is at 3. My amplitude, I said, was at 4. We're going to use cosine. I'm going to come back to that because this is always a tricky one. I want to move to the right, and since we're in radians, we're going to use x. Right 2 is going to be a -2, and the trickiest part, I do not put 12 in here. What I do put is I take 2 pi and divide by 12, otherwise known as pi over 6. So I'm going to take my 2 pi period. Multiplying by pi will shrink the pi right out of that, and I end up with a period of 2, and the dividing by 6 will stretch that 2 out to a period of 12, which is what I want. So there's my equation. Now, if I want to find where this is equal to 1, I'm going to replace my y with 1, right? And I can see, so I'm looking for this answer, this, and this. And I can guess what those are. I'm guessing it's at 2, at 6, at 10, and at 18. Let's see what happens when I go to my calculator, and put all of this in. Let's throw this over here. There we go, so I can hopefully still see it. So my y1, I'm going to put, oh, come on. So in my y equals, I'm going to put my equation, 3 plus 4 cosine, and then I'm going to put, I don't need this, I'm going to need pi over 6, and then I'm still inside my cosine, x minus 2. So there's my equation, and I could close up my parentheses or not, it doesn't really matter, and I want to find out where that equals 1. And I believe I am in radian mode. It's always a good idea to check that. Here I have a graph. I'm actually going to make my window look like the window I have over here. So I'm going from -4 to about 20 and -1 to 7. So -4 to 20 and going up by 2. And what did I say? I think -1 to 7. And that would be going up by 1. So there's the graph. That should look very much like what I have on over there. It does. And so if I want to find all these places, I am going to intersect. Second trace, which is intersect, and go down to 5, or you can just type 5. And it's going to ask me first curve, which is this right up here at the top. This guy right there. That is what I want. I'm going to hit enter. And then I can do my second curve is y equals 1. I want to hit enter. And if I just hit enter, it'll take me to the nearest one. But I want to go to the very first one. So I have a couple options. One is I can move my cursor over. But that is sort of tedious. The other one is to take a guess. If you guess, I'm going to type in, I thought that was at -2. I'm going to type in -2. And it is indeed at -2. That's where y is 1. I can find other solutions by repeating the process. You can't just go to the next one. We want to intersect. We don't want to trace. So I'm going to intersect y1, enter. Yep. Is that y2? Yes. Guess. Now I'm going to guess. What did I say? Is it closer to 4, 5, 6, something like that? Let's guess 4. Oh, and it was 6. So I was a little bit off, but it's 6. It took me to the closest one. I can try again. Second intersect. That's a 5. And y1, y2, if that was 6, that's 8. So it was somewhere around 10. Let's try for my guess. And again, you don't have to guess. You can use your cursor. I'll try that on the next one. But I like the cursor, or the guessing is faster. I intersect y1, yes. y2, yes. And we can always move closer. It will find you the intersection that you are closest to. And I think I'm at least over halfway. Enter. There it is, 18. So all those answers I guessed are correct. We just showed that using our calculator, so numerically. Now I can solve it algebraically as well. So I'm going to take my equation, which is 1 equals 3 plus 4 cosine pi over 6 x minus 2, and I'm going to solve that. So my first step is to undo the adding. So I'm going to subtract 3, and I get -2 equals 4 cosine pi over 6 x minus 2. I still have one more outside transformation. That's my 4. And I get -1/2 is cosine of pi over 6 x minus 2. In my head, I'm thinking, ooh, -1/2. I could actually finish this without my calculator. But we have the calculator, so let's keep going. Now is the time. I have undone all my outside transformations. Now is when we inverse cosine or inverse sine. We use our general solution, or we find our answers. So what I'm left with is this is still going to be there. I don't deal with that until after I actually find my angles. So I'm going to switch the sides. Pi over 6 x minus 2 is equal to plus and minus cosine inverse of -1/2 plus, in radian mode, 2 pi n. And I am actually going to split this up. The plus and minus I find confusing when it comes to actually getting my answers. So I'm going to make it very clear that I have two different answers. And each of those answers so far is what pi over 6 times x minus 2 is equal to. All right, let's group those together. Okay, so I can move that around. Right now, I still want to know what x is. So I'm going to undo multiplying by pi over 6. And I undo by multiplying by 6 over pi. That piece and that piece. And then again, this piece. Right? And so that leaves me x minus 2 is 6 over pi times cosine inverse of -1/2 plus, my pi's are going to cancel, and I'll get plus 12n, which is awesome because we said our period was 12. Here it is. More answers come by adding or subtracting multiples of the period. That is exactly what I should have had. So I know I'm on the right track. X minus 2 is -6 over pi cosine inverse of -1/2 plus 12n. Now that's still not what I want, because my final answer, I need to add my 2. And so here's my one solution. 6 over pi cosine inverse -1/2 plus 2 plus 12n. And remember, as far as this goes, no, not that right there. This is one starting angle. And if I come down here and do the other one, so let's do this, I get x equals -6 over pi cosine inverse of -1/2 plus 2 plus Solv n. And again, this is my other starting angle. So when I go to my calculator to come up with these two separate starting answers, I am going to do 6 divided by pi. Whoa, that is not divided by. Let's try it again. 6 divided by pi. And I multiply that by cosine inverse of -1/2. I'll close that parentheses. And I take that answer plus 2. So there is one starting answer. And then I can get more answers by adding and subtracting my period. 18. I think that's as far as I went. Maybe I needed to subtract. 6 minus 12 would get me -6, although I don't know if it said what answers I was looking for. So anyway, I have my general solution. My general solutions are already there. If I need them on a specific interval, I could start doing more or fewer, depending. I could keep going if I needed to. But there I have two answers, 6 and 18. Now I still have more answers. And that comes from doing -6 divided by pi times cosine inverse. Oops. Ooh, okay, let's try it again. So -6 divided by pi cosine inverse -1 divided by 2. Not -11. -1. And I'm going to take that answer and add 2. And that gets me a different starting answer. There's my -2, and then I could add multiples of 12. And there's the 10, and so forth. I could do more. So I have a general solution, and I have all my solutions. You can also do it as you go. So if you are more comfortable doing, okay, I have my cosine inverse of -1/2. Boom, there's the answer. And then I take that, and I'm going to multiply by 6 over pi. 6 over pi. And then I take that, and I'm going to add 2. There's, whoa, error syntax. Too many pluses. Let's try it again. So let's do 4 plus 2. There's my first answer again of 6. That same first answer that I had right here. So you can do it step by step when you're trying to find particular answers. Now you should be ready to try some of the mastery problems. And make sure you pay attention on your axis. So as you're looking at graphs, if there's an x, we want to be in radian mode. And if there's a theta, we want you to do everything in degree mode. So you should be good to go.